We've been doing a lot the last couple of days with exponents and simplifying things with exponential powers. So today we're getting into radicals. Anybody tell me what a radical is? I just told you what it was.
Exponent. No.
Roots. Okay? It's roots. So, definition. A radical is terms containing roots. All right? And to simplify a radical means writing a radical in simplest form with an exact answer, not an estimate. Okay, so radicals is a term containing roots, and simplifying a radical means to find the exact answer, not just an estimate. Now, before we go any further, how does a root work? If I say the square root of 16, what's that asking? Don't give me the answer. What's it asking? What does a root mean?
The simplest form.
What does a root do? It's not on the screen. I'm looking for two possible answers here.
It's
Roots help grow the tree. They get moisture from the soil.
It's the number that multiplies by itself and yet.
There you go. Yep, the number times itself. Okay, it's saying what number times itself is equal to what's inside the root. All right. The other thing you can say is it's the opposite or inverse operation to squaring something. Okay, so something like this. If I say the square root of 16, like I mentioned, says what number times itself is equal to 16? Well, we know that as what? 4.
Close enough.
All right. So, just to recap, perfect squares. Okay, perfect squares are roots that come out even every time. So, let's do this. Let's do the perfect squares chart really quick here. We did this earlier this year, but I just want to do it again. Okay. 1,
3.
1, 2, 3, 4, 5, 6, 7. Okay, so those are all my bases of x. So then x squared. What's 1 squared?
1.
2 squared.
2.
3 squared.
4.
4 squared. 16. 5.
20.
6. 7. 8.
56. 6 times 7, 56.
Knock it off. 64. 9. 10. 11.
I don't know.
12.
144.
Okay. So, the ones up top are just my base counting numbers. Okay. The ones in the bottom are the squares of all those. If I'm going to square a number, if I want to square a number, I go from top to bottom. If I want to square root a number, I go from bottom to top. Remember using that? Okay. So, if I have the square root of 25, what's that going to be? 5. Because it's right here. 5 would be what it pairs with. Okay. Square root of 100. 10. Square root of 49. 7. So all these numbers are found here and here. So you can use those because they're perfect squares. And you get a nice even number every time. Right, those are the simple ones to do. Now, is every number going to fall in there? No, definitely not. Because, I mean, if I look in between 121 and 144, there's 23 numbers that fall in between those two, right? So there's a lot of numbers that are not covered in these. You're way more likely to have a number that's not a perfect square than a number that is a perfect square. Okay? I'm just talking about in the world, not necessarily in this class. All right? So here we go. This is how we get non-perfect squares. So non-perfect squares, the only option we've had to this point is a calculator or estimation. Okay? Here's the problem. Somebody get a calculator out.
I can't find one.
What's the square root of 27?
3. 7.
5.196152423.
Okay, it goes on forever, doesn't it? Does that number ever stop? No. All right, this is an irrational number. An irrational number goes on forever. It never repeats. It never terminates. Okay, so it's irrational. The problem with that is you never get an exact answer. Okay, think about like 1/3. What's 1/3? It's 0.333333333, right? 2/3. It's 0.666666666. But what happens? We usually end up going 0.667 a lot of times, right? So we have to round it. So that's never an exact answer. The other thing you could do, you could estimate it. All right, square root of 27, that's going to fall between 5 and 6, right? So you could say between 5 and 6. It's not a very satisfying answer, though, either, is it? All right, what if we want an exact answer? Because right now, all I did was an estimation and an approximation. Okay, there's got to be some way to simplify these and keep them as exact answers, right? So let's look at this. This is what we have called breaking down a root. So you break down a root, you're going to take the number inside the root and break down by prime factorization. Do you guys remember prime factorization? This takes you back to elementary school days here. Okay? So prime factorization. Let's go with this number. Let's go 50. All right? I'm not even doing a root right now. All right? I am just doing prime factorization for 50. So if I have 50, then we made these little factor trees. What's two numbers that multiply together to get 50?
50 and 1.
Okay, other than 1.
Um,
25 and 2.
5 and 10. All right, 5 and 10. 5. Can I break down a 5 at all? No. So then what you did, you circled it, right? And then 10, can I break it down?
yeah.
2 times 5.
2 and 5. Are those both prime numbers? Yes. So then you circled it. So then the prime factorization of 50 would be 2, 5, and 5.
How do you know they're prime numbers?
What's the definition of a prime number?
The base, you can't go any lower.
Because it only is divisible by
1.
and
Another number. By
One.
itself.
1 in itself. Prime number is a number that's only divisible by 1 in itself. So in this case, my prime numbers were 2, 5, and 5. So the factors of 50 is 2, 5, and 5. Do you guys remember doing this?
Yeah. 2 and 5 squared. Is that same or no?
If you want to look at it that way. All right. So why does this matter to us? Okay, why does this matter to? Well, a square root is just the opposite of a square, correct? So if I had 5 times 5, that's 25, right? What's the square root of 25? 5. What did I need? I needed two numbers. That's what I'm going to look for inside my radical. If I have two numbers, so let's make this the square root of 50. Well, the square root of 50 is equal to the square root of 2 times 5 times 5. Okay? So a square undoes a square root, correct? Right here is 5 squared. You with me? So I could also rewrite this as this, the square root of 2 times the square root of 25. Because I just did 5 times 5. So I have 5 root 2. I just simplified this. It's multiplication, so I can change the order. All right, so 5 root 2 would be the exact simplified answer of the square root of 50.
Wait,
Alright.
what's that 275 squared then?
That's a 25.
Oh.
I just rewrote this guy. All right, so what do we do here? Well, this is what you want to do. You want to look for pairs. Now, this is only for square roots. All right? In every pair, bring out one of that number. So above there, I had a pair of 5s. If I have a pair of 5s, I can bring 1 5 out front. Okay? So you want to look for pairs, and that's only for a square root. We'll talk about higher order here in a little bit. But you want to look for pairs. Every pair, you're going to bring out that number out front. So if you have 2 pairs, so if there's 4 5s, you can bring out a 5 and a 5. One number for each pair. Then out front, you'd have 5 times 5, which is 25 then. Still with me? Okay. So let's try some. You have this written down? You ready if I move to the next page?
Oh, we have to write that down.
Yeah, I mean, it is notes. So, all right. Let's go with the square root of 40.
Wait, are we doing this by
So,
ourselves?
we'll do this one together, and I'll give you a couple to try yourself. All right, so the square root of 40. Now, if you can rewrite these, we'll get to a point that you'll probably be able to do some of these in your head. Okay, like I can look at that right now and go, 2, 2, 2, 5. You know what I mean? So, but you'll get to a point where you can do that, or at least start to. All right, but let's do the prime factorization. So, 40. How can I break down a 40?
20 times 2.
20 times 2, okay? How about 20?
10 times 2.
10 times 2. 10?
5 times 2.
5 times 2. Okay, so there was the 2, 2, 2, 5, like I told you. Do we have any pairs in there?
Yeah.
We have one pair of 2s, right? So I always like to do this. 40, and then if you need this, that's great. If you don't need this and can go straight to here, that's fine. But I always like to write it out with the factors inside. Okay? It's just a good place to be. All right, so then I'm going to underline my one pair. Is there any more pairs other than there's 2 2s? No, there's an extra 2 and then a 5, but there's nothing to pair with those, is there? So because I have a pair of 2s, what do I do with that 2? Bring it outside. So I have a 2 out front. Now, inside then, what am I left with inside? A 2 and a 5. Well, then just multiply them back together. What's 2 times 5? 10. We took 2 2s out. There's 1 2 left and 1 5 left on the inside. So you took the pairing of 2s here. You took that outside. Left with a 2 and a 5. Okay? You with me there? All right. I'm going to give you 2 to try. Let's go with square root of 24 and the square root of 63. Try those 2 guys out. Square root of 24 and the square root of 63. All right. So if we look at the first one, 24. Square root of 24 is going to be 2, 2, 2, and 3. Good. All right. 2, 2, 2, and 3. I have a pair of 2's. I can take them outside. So 2 root 2 times 3 is 6. How many people got that one for an answer? Good. You good?
Yes.
Okay. Did you get 2 root 6 for the first one?
Yes.
Okay. All right. Next one. 63. 63 is going to be 3, 3, and 7, right? Pair of 3's. Take it outside. And we get our 3 root 7. I like it. Who had 3 root 7 for that one? All right. Now, let's go with a couple more here. I think it's pretty easy. What happens? I want to do one together, then I'll give you a couple more. About the square root of 32. So the square root of 32 is
16 times 2.
16 times 2, 4
4 times 4.
times 4.
2 times 2. For both of them.
Yep. All right, so this is going to be 2, 2, 2, 2, and 2. Right? So we got 2 pairs here and here. Okay, so out front I have 2 times 2 with a root 2 left. What's 2 times 2?
4.
4. So 4 root 2. Guys with me there? All right. How about the square root of 200?
20 times 10.
Okay, so 20 and 10. Okay,
5 and 2 and 10 and 2.
so 5 and 2 and 10 and 2. Are we done yet?
Nope.
Another 10 and 2, or 5 and 2, right?
Yeah.
All right, so this guy is going to be, what, 3 2's and 2 5's?
Yeah.
2, 2, 5, and 5. Now, just be careful here because we have 2 numbers we're bringing out. We have a pair of 2's and a pair of 5's. What's 2 times 5? 10. What's left inside? 2. Is that right with that? Okay. All right, I'm going to give you 2 more here to try. Let's go with all right, the square root of 600. And let's go with 288. Okay, I'll give you a few minutes to try those two. Square root of 600, the square root of 288. First one, we have the square root of 600. So the square root of 600, we broke it down, was 60 and 10. 10 was 2 and 5, good. 60 was 30 and 2. 30 was 10 and 3. So then 2 and 5. So we broke it the whole way down here. We have 1, 2, what, 3 twos? Is that right?
Oh, I missed.
So 1, 2, 3 twos. And then we have how many threes? Just one?
Singular.
1, 3, and 2 fives.
Yeah.
Does that look right?
Yeah.
All right, so now after that, we pair it up what we can. So a pair of twos here, pair of fives here. So 2 and a 5 out front is going to give me what? 10. And then 2 times 3 in the inside is a 6. So 10 root 6. How many people got that one? Okay. All right, 288. So 288 was 2 and 144. 144 was 2 and 72. 36 and 2. 6 and 6. All right. So 2, 2, 2, 2, 2. 5 twos. Is that right?
Yeah.
So 2, 2, 2, 2, 2. So 5 twos and how many threes? 2 threes. Okay. So pair of twos, pair of twos, pair of threes. So I have 2 times 2 is 4, times 3 is
12.
12. And then left inside is a 2.
My answer.
Questions on that, guys? Not terrible, right?
Mm-mm.
Now, what happens if I get something like this?
Always what happens.
It's not always what happens. I'm just going to use these same 4 problems. I hope you wrote them down because I just broke down all these. And what if I change this to a third root?
Then I'm
Change
screwed.
your numbers.
Add them together and then subtract.
Okay.
33 times.
All right. I'm going to make all those ones third roots and this one a fourth root. Okay. So here's what happens. Absolutely nothing changes on the breakdown. Okay. So cube root of 32 is still going to have 5 twos. 1, 2, 3, 4, 5. Okay, it's still 5 twos. But what's that little number out there? It's a 3, right? It means cube root. It means what times itself 3 times is equal to what's inside. Okay? Now, with whatever that number is, that's how many I need in my pairing. So before I just needed a pair of twos, right? Now, if there's a little 3 out there, that just means I need groups of 3.
Trio.
So now I have a group of 3 twos. So that goes out front. Oh, sorry, not a 3. A 2. It's a grouping of 2s. So that grouping becomes 1, 2 out front. And now I have root 2 times 2, which is 4. Okay, all that little number does is tell me how many of every one I'm looking for.
Why you still got that little number?
Okay. Because it's still there. The root's still there. It doesn't change the root. Okay? So if it's a third root, fourth root, whatever it might be, it doesn't change the number. It just changes the groupings. Make sense? If there's no number that's a square root, anytime it's a square root, you're looking for pairs or groups of 2. If it's something higher than a 2, then you are just looking for groupings of that number. Third root, you're looking for groupings of 3. Fourth root, groupings of 4, and so on and so forth. Okay? So, then 200, what was the breakdown for 200?
2.
2, 5, and 5, right? Okay, so here, do I have any groupings of 3s?
Yeah.
Which ones? 2s. So now that group of 2s comes out front, 2. Third root of 5 and 5 is 25. You with me?
Yeah.
The only thing what changed was I need 3 of a number to bring it out front instead of 2 of a number. And that's because of that little 3 here within the, inside the root. So those 2 that you just did, all right, 600. What was the breakdown for 600?
300, 2, 2, 2.
Just give me all the numbers.
Wait.
How many
2,
2s?
2, 2, 3, 3, 3. Wait, never mind.
Which two, two,
I'm in a
two,
different problem.
3 2s, 1 5, or
And 1
2
3.
5s and 1 3.
Okay, thank you. So that was the breakdown, right? 2, 2, 2, 3, 5, 5.
Yeah.
Anything, there's a group of 3 here.
Maybe. Yeah.
There's 3 what?
2.
3 2s. Bring that out front. Is there anything else I can bring out?
No.
No. So that gives me a third root of 3 times 5 times 5. That's what, 75?
Yep.
You didn't even check. You just agreed.
No, I knew it was 75.
All right, last one. 288. What was the breakdown for 288?
2, 2, 2.
5 2s and 2 3s.
5 2s and 2 3s. Okay. Now I have a fourth root out front. Right? So now I need a grouping of how many?
4.
4. Do I have 4 of anything?
Yeah, for 2.
I got 4 2s. So I bring that out front. 2, fourth root of 2 times 3 times 3, which is 18. You guys all right with that? Okay. All right.
I think 2 is the most common number.
Alright, I'm ready for homework.
Twos are going to be crazy on these. They really are.
Yeah, number 7 is obviously.
All right. I'm going to give you 3 problems. Get these 3 done. We're done. You can start on your homework.
Alright, I'm good.
So, here we go.
What if I had a dream?
Then you slept well.
I've had dreams this morning. Does that mean I have slept well? No. I just said shit. I had a dream last
Imagine
night.
sleeping.
I had a dream. I had a dream
There's
last.
caffeine tablets or something.
I had a dream last night.
I had a dream, it's a really good one. It was
Right.
one where you get
What happened to your
another
dream?
one.
What?
Okay. So, there's a square root, a cube, and let's go another cube. Okay? There you go. There's your 3. So the first one, we have 128. 128 is going to be how many twos? It's like 7 of them. I agree. So if there's 7 twos, there's 3 pairs. So 2 times 2 times 2 is going to be 8. Root 2 left over. I agree. Second one, the third root of 96. 96, we get 2, 2, 2, 2, 2, and a 3. So 5 twos and a 3. We need groups of 3 to bring out. So we have a 2 we can bring out front. And then left on the inside, there's 2 twos and a 3 left over. So 2 times 2 is 4 times 3 is 12. So we have 2 third root of 12. Is that what we had?
I had 8. I thought you multiplied them.
Yep, we multiply. Sorry. Yeah, this is right. It should be 2. You do not multiply when you bring out because that was your one grouping. Okay? All right. So yeah, we had 2 third root of 12. So it was really close. All right, last one, 54. 54, we had 2, 3, 3, 3. 3, 3.
I got.
Yes.
Yeah.
Yes. So 2, 3, 3, 3. I have one group of 3. I have 3 threes, so I can bring 3 threes out front. So I have 3. Third root of leftover is a 2. I agree. Questions?
Wait, no, go back.